Good afternoon, dear students. Today's class we will discuss general characteristics of the compound of alkali metals. Generally, alkali metals are ionic in nature. They can form some compound with other salt like oxygen and maybe combine with the carbonate, phosphate, sulfate. They can form oxides, hydroxide, then oxosalts, halides. So, in this session, we will discuss about the general characteristics of the compound of alkali metals. That means alkali oxides and hydroxide, then halides and oxo acids. First general characters of the compound of alkali metals are oxides and hydroxides. This one and hydroxides. How alkali metals are formed, oxides and hydroxides. And reaction with oxygen, generally alkali metals are reacting with oxygen. That means the combustion process is generally going on between this alkali and oxygen for forming oxides. This formed oxide, because of this combustion process, then that formed oxides are react with water, they form hydroxide. Generally, this hydroxide of this alkali metals are basic in nature. So, the reaction between metal and oxygen, metal plus oxygen form oxide. So, metal plus oxygen, they form oxides. So this process is known as combustion process. So combustion process is a explosive process, and when we treat this alkali metals with the oxide, they can form metal oxides. Then treating this metal oxide with water or reacting this resultant of metal oxide with water, they can result hydroxides. So M2O, this is metal oxide and it is reacted with water. What is the formula of water? H2O. They can form hydroxide. So if they are forming the hydroxide, means what will be the result? MOH. MOH. OH is denoting it is hydroxide. Okay. Hydroxide. Then how it's formed? MOH. So totally two molecules of MOH. 2M, 2 hydrogen and 2. So totally 2 MOH. So they form hydroxide. So in alkali metals, all other alkali metals can form peroxide except lithium. So lithium cannot form peroxides, but other all the metals can form peroxide. Okay. Can form peroxides. So the reaction for forming peroxide is treating all the alkali metals under the combustion process with the oxygen in the excess amount of oxygen. Okay. So if reacting the alkali metals in the presence of oxygen with excess amount, they can form peroxide. So in the formed peroxide or from the resultant of this combustion process, we use that resultant peroxide again treating with the water. They can produce hydroxide of the particular alkali metal and forms hydrogen peroxide as a byproduct. So the reaction between that alkali peroxide with water. So you know that peroxide, the formation of peroxide because of the combustion process in excess amount of air. So in the excess amount of air, they form peroxide, not oxides, peroxide they form. So that peroxide M2O2 is combined with water. It is combined with water, and they can form, the result are MOH. This is MOH means alkali hydroxide. So they form hydroxides and hydrogen peroxide, H2O2, hydrogen peroxide. So now you can take this M2 to M. Then 2 molecules of M, then O2, here also O2. So one O2 is combined with the M and one O2 is combined with hydrogen. Two hydrogen is combined with 2 oxygen. Then remaining 2 hydrogen is combined with MOH. Okay, MO. So it's become hydroxide, and the byproduct hydrogen peroxide. Here M is denoting at sodium, potassium, rubidium and cesium. Why not lithium? Because lithium cannot form peroxides. Okay, lithium cannot form peroxide. So in this reaction, metal is denoting sodium, potassium, rubidium and cesium. Okay. Next general character of the alkali metals are, except lithium and sodium, other alkali metals can form superoxides. They can form superoxide, but they can't form superoxides. All the alkali metals can form oxides except lithium. All the metals can form peroxide. Then the next exception case, lithium and sodium cannot form superoxide. They can't form superoxide, but all the alkali metals can form superoxides. So the formation for the superoxides are given below in the equation. Metal treating with the oxygen, this is superoxide of the metal. What are the metals? Potassium, rubidium and cesium. Because sodium and lithium cannot form the superoxide. So they can only potassium, rubidium, cesium can form superoxide. When we treat this superoxide with water, they can form hydroxide. The basic nature of hydroxide. Hydroxide is a basic compound, right? So superoxide can form hydroxide with the treating water. So treating this superoxide with water resulting hydroxide. So the formation of basic hydroxide from the superoxide, alkali superoxides, 2 molecules of MO2 plus 2 molecules of H2O, 2 moles of H2O. They react together and they form basic nature hydroxide, MOH. This is alkali hydroxide, and the byproduct H2O2 and also O2. Okay, then balance this equation, MO2 and 2H2O. Here 2M. So 2M combined with the 2 molecules of oxygen and 2 hydrogen. So now it's become 2M. From here you know totally 4 oxygens are present in this. So 4 oxygen, 2M. Here totally 4 hydrogen and 2 oxygen. Now balance this equation, M2 then 2O, 2O, okay, 2O, then 2 hydrogen. From this 4 hydrogen, it's combined here with the 2 hydrogen. So this is become alkali hydroxide. So the remaining 2 hydrogen and again here 2 oxygen. So this 2 hydrogen and 2 oxygen combined together as H2O2 hydrogen peroxide as a byproduct. Then the remaining 2 oxygen are evolved as oxygen. Here M is denoting that potassium, rubidium and cesium. Why? Because lithium and sodium can't form superoxide. Because of this we can write M only potassium, rubidium and cesium. So what are the properties are involved in oxides and hydroxide? Generally, oxides and peroxides are colorless compound. They are colorless compound in the pure state. In the pure state, oxides and peroxides. Oxides and peroxides are colorless compound in the pure state. The superoxides are yellow or orange in color. So superoxides yellow color or orange in color. Generally, peroxides of these alkali metals are diamagnetic. Peroxides diamagnetic. So superoxides, it's paramagnetic. Superoxides are paramagnetic. Sodium peroxide is widely using as a reducing agent. Oxidizing agent. The formed hydroxide from the reaction of oxides and water, they are generally white crystalline solids. So this hydroxides are pure white crystalline solids and they are strong bases. You know that hydroxides are generally basic nature compound, but in this alkali metal compounds, that hydroxide of this alkali metal compounds are strong bases and they dissolve in the water. And if you dissolve the water, this alkali hydroxide like sodium hydroxide, potassium hydroxide, rubidium hydroxide and cesium hydroxide, they can evolve when dissolve this salt, white crystalline salt, into water. They release some amount of heat because of dissolving into water. So the hydroxide dissolving the hydroxides of alkali dissolved in water is the heat evolution process. Halides, we learned already oxides and hydroxide. This is the general characters of halides. Alkali metals are forming halides when they are reacting with the halogens like halogens. What are the halogens? Fluorine, chlorine, bromine, iodine. Okay, so when this alkali metals are combined with this halogens, they form metal halides. That means alkali metal halide. So the general formula of this alkali metal halide is MX. They are colorless crystalline solid and they have high melting point. They are colorless crystalline solid. And high melting point. These alkali halides are prepared by the reaction of oxides and hydroxide or carbonate of this alkali halide with the hydrohalic acid. Hydrohalic acid means, example for this hydrohalic acid, hydrogen combined with the halogen acid, that means hydrochloric acid and hydrogen fluoride, hydrogen bromide, hydrogen iodide. When treating this hydrohalic acid with alkali metals, alkali oxides or alkali hydroxides, they can form alkali halides. In the electropositive character of this alkali metals are increasing from lithium to cesium. So it is easy to forming this or increasing the formation of this alkali metals is from lithium to cesium. It is increasing because the alkali metals are combined with the halogen with the increasing the electropositive character of lithium to cesium. Because of that, the formation of alkali halides from lithium to cesium, it is increasing. The general characters of this alkali halides, generally alkali halides are ionic in nature. But we have some exception in this ionic nature of this alkali halide, only with the exception of lithium bromide and lithium iodide. So except lithium bromide and lithium iodide. So these two are not in the ionic nature. Then solubility of this alkali halides, all the other metals, other halides can dissolve in the water or they are soluble in water except lithium fluoride. The low solubility of lithium fluoride in water because of the high lattice enthalpy and due to the smaller size of lithium and fluoride. So lithium also it is placed in the top of that alkali metals, and fluorine also it is placed in top of that alkali metals. So because of this ionic radius or smaller size of lithium and fluoride, because of that they have high lattice enthalpy, that's why they are not dissolved in water. With high solubility, they are low soluble. Okay, so other are can soluble in water. Then we saw this lithium bromide and lithium iodide, they are not in the ionic nature, that means they are not in the ionic bond, but they are in the covalent nature. So covalent nature means in between this lithium and iodine or lithium and bromine, we have the bond as a covalent bond. Because of this covalent bond, they can dissolve in the organic compounds like alcohol, benzene, benzenoic acid, okay, etc. So these are the halides formation and general characters of halide. Next one, salt of oxo acids. Generally oxo acid means they are carbonate salt, sulfate, nitrate and phosphate salts. So these salts are generally known as oxo acid. When alkali metals are combined with this salt, oxo acid salt, they can form alkali carbonate, alkali phosphate, alkali sulfate and alkali nitrate. So alkali metals can form the oxo acid with a combination of these salts. Most of the salts are soluble in water and they are thermally stable. They can soluble in water, thermally stable. Thermally stable means in that oxo acids, alkali oxo acids are the stable when we heating in the under the heating process also. So that character is known as thermally stable. So you know that the electropositive character is increasing from lithium to cesium. Because of this increasing electropositivity from lithium to cesium, the solubility of carbonate and bicarbonate is also increasing. So this is only because of decreasing the polarizing power of alkali metal cation. Increasing electropositivity from lithium to cesium. Because of this it is increasing the stability of carbonate and bicarbonate due to the polarizing power is decreasing in the alkali metal cation. So all the alkali are metal cation, so it is decreasing the polarizing power. Because of that they are stable. Carbonate and bicarbonate of alkali metals are stable. So the carbonate metals, the alkali metal carbonates are stable up to increasing temperature 1273 Kelvin. So in up to this temperature they are stable. Alkali carbonates are stable. When increasing the temperature above this given temperature 1273 Kelvin, further increasing, they first melt. That alkali metal carbonates are first they will melt and they can decompose. Further increasing the temperature, they decompose to form oxides. Increasing temperature above 1273 Kelvin, first it melts and decompose to form oxides. But with all the other metals, lithium carbonate is less stable and they decompose easily. So the formation for this decomposition of this lithium carbonate is given in the equation. Li2CO3 undergo heating process, they produce Li2O, lithium oxide, and carbon dioxide as a byproduct. So lithium combined with one oxygen from carbonate, that means oxo salt, and remaining CO2 is evolved as CO2 gas. Why it is readily decompose not like other alkali oxo acid? Because of the different size of this metal. So lithium is a smaller size ion, metal cation, and carbonate is a large one. So because of this variation of size, it can easily decompose, undergo the heating process. So because of this larger size, this size differentiation make the crystal lattice is unstable. That white crystalline solids are unstable because of this size, variation in size. That's why it can decompose easily. They can form solid bicarbonate other than lithium because of this strong basic character. So no other metals can form bicarbonate, but lithium can form the solid bicarbonate. Other metals cannot form solid bicarbonate. So the reaction for this, M2CO3 carbon dioxide, H2O, they form metal bicarbonate, metal alkali bicarbonate. So what are the metals are involved in this? Then sodium, potassium, rubidium and cesium. All the carbonate and bicarbonate are soluble in water, but their solubility is increasing rapidly. It is increasing with the descending the group. So this is due to this reason, lattice energy decreases more rapidly than their hydration energy when moving from the group 1 lithium to cesium. So these all are the general characters of alkali metals of compound. So today's session over. Thank you, students.